Hey, we're talking about graphing systems of linear equations and inequalities today. So remember that when we have two linear equations or two equations of lines and they cross and hit at one point, this is called a solution. That point, whatever it is, x comma y, will make both equations true, okay? So when we're graphing linear equations, remember there's three forms we can see this in. The first one is slope intercept form, and that's because in this form we see the slope right here and we see the y-intercept right here. So for example, to graph this, if I know this is y equals mx plus b form, I know here's my slope, right? So here's the slope. And if I know the slope is 2, I can also write that as 2 over 1, and that's the rise over the run. I also know that the b value, or the y-intercept, is 1. So remember, the intercept is the b value. So I'm going to start here. So we have a value on the y-axis of 1. That's my starting point. And then I'm going to use the slope of rise over run. 1, 2, rise, run, 1, positive, and there is my line. Okay, so if I have two linear equations that I need to graph, I'm just going to do that 2 different times, right? For point slope form, remember, point slope form tells me a point on the line, which is x1 comma y1, and the slope here is m. So let's say, for example, I see this right here where I have y minus y1 times m, or equals m, times x minus x1. So the way we're going to do this is y1 m x1. And we identify it because it comes after the minus sign on this form. So a couple of things. I know the point x1, y1 is really 1 comma 3 because those values come after the form x minus or y minus. So let's graph that first point, 1 comma 1, 2, 3. There's my first point. And then from there, I'm going to use the slope, which I know this is the slope. It's negative 1 over 2. So for a slope as negative 1 over 2, I'm going to rise a negative 1 and run 1, 2. There's my next point. I could also always do it the other way where I can rise a positive 1 and run a negative 2. Either way, it will give you the same line. Okay, and if you have two lines in those forms, you'll just do it again for the other line and see where they cross. And then lastly, if something's in standard form, remember we have ax plus by equals c. This really doesn't tell me the slope, it doesn't tell me the y-intercept, but it does quickly tell us using the cover-up method, it can tell us the intercepts. So remember, if I cover up, if I'm looking for the x-axis or the x-intercept, I can cover up this and I can find out the x-intercept. If I'm looking for the y-intercept, I can cover up the x part and I can find the x-intercept there as well. Okay, so let's look at this example. So if I'm looking for this, I want to know what the intercepts are. So if I'm looking for the x-intercept, remember that's where y equals 0. So I'm literally going to cover up all of this. So I see 2x equals 12. Well, I know if 2x equals 12, then x has to equal 6. I can put that on the x-axis. So if this is 2, 4, here's 6. Here's my x-intercept. And then if I'm looking for the y-intercept, if I'm looking for the y-intercept, I know that x equals 0. So I'm going to cover up the x value, and I get 3y equals 12. Well, I know in that case, y equals 4. So I'm going to choose 4 on the y-axis. Those are my two intercepts. I don't need to know the slope because I've got 2 points, and I can connect the dots. If you've got two equations like that, you just do it twice and carefully find the solution. Now, on graphing linear inequalities, what we're going to do, it's the same as graphing just regular linear equations. The only difference depends on which inequality we see. So if I see a greater than or less than sign, this means we're going to do all the same steps, but we're going to have a dashed line. And if we've got a greater than or equal to or less than and equal to, it means we're going to have a solid line. And then you're also, if you have an inequality here, you're going to shade the side that makes it true. So that means pick a point on either side and see if it makes your inequality statement true. So let's look at this one. It says graph x plus y is less than 4. So this looks a lot like that standard form, even though it's an inequality. So I know if it's in standard form, I can find the two intercepts pretty quickly. I know that the x-intercept is where y equals 0. So I'm going to cover this up for just a second. That tells me that x is at 4. So I'm going to put, when x is at 4, I'm going to put that right here, or right here. This is 4, right? And then I'm going to erase that. And then if I'm looking for, I'm going to write that down, x equals 4. And then for the y-intercept, I know that x equals 0. So I'm going to go through and I'm going to cross out the x value, and I know that the y-intercept will be at 4. So I'm going to go up 1, 2, 3, 4. Now, those are my 2 points, but remember how I said, depending on the inequality symbol, it may be dashed or solid. I'm looking at this right here. This tells me it's going to be dashed. So I'm going to draw my dashed line. And now I'm going to pick a point on either side of the line, and I'm going to see which one makes it true. If you can ever pick 0, 0, I say do it. So if 0, 0 is not on the line, I'm going to pick this. So I'm going to see, is the point 0, true? Does it make it true? So if this is x and this is y, I'm going to plug these into here. So x, which is 0, plus y, which is 0, is that less than 4? The question, yeah, it is. So 0 plus 0 is 0. Is 0 less than 4? Yes, it's true. So I'm going to shade that side. Okay, and then if you have two inequalities, you just graph the line, dashed or solid, and again, pick a value that will make the shading true and see where they overlap. Okay, last one. What if they give you something like this and it says graph this inequality, and it looks like it's almost in, it looks just like it's in y equals mx plus b form, or slope-intercept form. So I'm going to graph it as if it's just that line. So it looks like y equals mx plus b. So this tells me the slope, and this is the y-intercept. So the y-intercept is here at -1. That's my y-intercept. And my slope is going to go rise 2 over 1. So from that point, we're going to go up 1, 2, and go over 1. There's my next point. Now remember, before I connect the dots, I'm going to look here at the inequality, and that tells me it's greater than or equal to, so we can use a solid line. And now in order to shade which side makes it true, I'm going to pick 0, 0 because it's not on the line. Let's see. So if we choose 0, 0 as x and y, which is 0, is greater than or equal to 2 times x, which is 0, minus 1. Let's see if it makes it true. Is 0 greater than or equal to 0 minus 1? Well, let's simplify. 0 is greater than or equal to -1. Yeah, 0 is greater than -1. Makes it true, so we can say yes. So whatever point that side was, we're going to shade that side. All right, guys, thanks for taking notes with me. Turn this in, and I'll see you in class.